Hi, hello, welcome to a Physionic detailed study analysis. Today we're going to be going over 8 studies to find out actually a number of different things related to Tadalafil, also known as Cialis. So Tadalafil is a phosphodiesterase inhibitor, so we're going to go into the mechanisms of action for that particular drug, and its effects on testosterone is the number one thing, and the second thing that we're going to be going over is erectile dysfunction. So if you're interested in having a comprehensive education on how Tadalafil works, if it works, how effective it is, and a number of other things, then you're in the right place. With that, if you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD candidate in molecular medicine. And this is what I do. I read studies, break them down, put them all together, and then present them to you so that you can look at the data for yourself and make up your own mind. If you don't want to stick around for the entire video, I usually get a few comments of people saying TLDR, what's the shortened version? Then you can certainly skip over to the conclusions, and then you'll get a summary of the results. But in reality, there's a lot of details that you end up missing. Unfortunately, that's just the way it is. If you want a comprehensive education, you have to invest time and effort. So with that out of the way, let's go ahead and jump into this. We're going to be going over, as I mentioned, the understanding the actual mechanisms. Then we're going to go into a review of the evidence specifically towards testosterone, so on a focus on testosterone. And then I'm going to shift gears and look at the evidence on erectile dysfunction. Now, if you're part of my Insiders group, Insiders program, then you'll also get access to about 30% of individuals that take Tadalafil or other phosphodiesterase inhibitors do not experience any sort of effect, if that's in testosterone or erectile dysfunction. So I'm going to offer some explanations and some studies that specifically look at non-responders. And then we're also going to go into how to improve the odds of effectiveness for people that are non-responders, as well as the optimal dosing across all the studies. So I look at the dosing across all studies and put it all together to find what's the most optimal dose. So if you're interested in accessing this, then certainly join my Insiders program. You can find a link to that, or I'll add a ticker that shows up on the screen. And otherwise, if you're just interested in the science itself, then let's go ahead and jump forward. All right, so let me remove myself real quick so you can see the study here. We're going to be going over, as I mentioned, 8 different studies. I'm going to go over the funding sources and all that stuff as we go through each study. They're not going to be in order, but I'll have a marker so you can know which study number that we're talking about. Also, I'll have my notes attached so you can see any amendments that may apply to this video afterwards, as well as the funding sources and links to the DOI numbers so that you can actually look these studies up for yourself. All right, let's go into the mechanism. Initially, we're going to look at, so I realize that this looks a little complex. We're going to walk through it, but we're going to initially look at the effect that phosphodiesterase inhibitors like Tadalafil, like Cialis, or that's kind of the brand name, I suppose, but you'll see Tadalafil a lot more often than you'll see Cialis. So like Tadalafil, how those actually have an impact within our cells. So in relation to erectile dysfunction first, and then a proposed mechanism for how they might have an effect on testosterone as well, and how testosterone can have a symbiotic relationship with the effect that it has on erectile dysfunction. So we're going to start over here. We're going to start outside of, so this would be like an endothelial cell, a cell that essentially regulates the size of the blood vessel. So you have a blood vessel, and you have blood flow going through it. Well, the lining of either all the way around, like a tube, the lining of that blood vessel is filled with this single line of what's known as endothelial cells. And these endothelial cells have significant impact on the modulation of the size of the vessel. So does it expand? Does it become, does it go under vasodilation, or does it go under vasoconstriction, where you have less blood flow and therefore you're also increasing the blood pressure in that region? Now, additionally, Another aspect that can impact this is your neurons. So you have neural inputs. So you have neurons that extend from, let's say, your spinal cord for the peripheral nervous system to particular sections of your body. So that can be your foot, but it can also be your penis. And when it gets to your penis, it has this small area called the synaptic cleft, which is a small opening between the neuron and the endothelial cells and other smooth muscle cells that would be in that region. So the smooth muscle cells are the ones that actually lead to the production of an erection. And those neurons can then deposit or release particular molecules. And one of those molecules that's shared between neurons as well as with endothelial cells is this one right here, nitric oxide. So nitric oxide gets released, and what happens is it crosses over into the smooth muscle. So this is all inside the smooth muscle over here, and this is all outside of the smooth muscle. So nitric oxide can find itself in the smooth muscle, which will then activate a protein called guanylate cyclase, soluble guanylate cyclase, which this enzyme then takes molecules of GTP, which are found within the smooth muscle cell, and convert them to cyclic GMP. So from guanine triphosphate to guanine monophosphate, cyclic GMP. And then this cyclic GMP can do two main things, at least for our discussion. One is that it can activate PKG, which is another enzyme. So this protein kinase G, PKG, will then have a series of different effects. Once it is activated by cyclic GMP levels increasing, so as cyclic GMP levels increase, then you have greater activation of PKG. This PKG then activates a protein called myosin light chain phosphatase and will inhibit its antithetic protein. So we've got myosin light chain phosphatase, we've got myosin light chain kinase, and these two are kind of opposing forces to one another. So if you have greater activity of myosin light chain phosphatase, you have greater smooth muscle relaxation. If you have greater activity of the kinase, then you have less smooth muscle relaxation. So that means that you have less blood flow going through the penis because the vessels are constricting if you have less blood flow. If you have greater activity of this kinase, then you have less blood flow and therefore you have less ability to generate an erection. So you typically want more activity of the myosin light chain phosphatase and less activity of the myosin light chain kinase. So those are two of the mechanisms. Now there's other mechanisms, however, as well. So one of them is that it inhibits the influx of calcium from outside of the cell into the cell, as well as in a region called the sarcoplasmic reticulum. I'm not going to go into that too much because it works through relatively similar means in terms of the overall idea that if you have calcium that enters into the smooth muscle cell, then you have contraction of the smooth muscle cell. And if you have contraction, then again, you're squeezing in on that area and reducing the blood flow of that blood vessel. That blood vessel starts to shrink. So you don't want calcium to enter the smooth muscle cell if you want the smooth muscle cells to relax, right? Contraction would be the opposite of relaxation. So PKG also has an effect where it reduces the intake of calcium. Now, additionally, it also accelerates or accentuates the release of potassium. So all your cells have what's known as a cell membrane potential, meaning that the inside of the cell is more negatively charged than the outside of the cell. And if it maintains a negative charge, then that means it is, for a lack of better words, this isn't exactly accurate, but for a lack of better words, it's in its quiescent state. It's not in its activated state, which again speaks more to this relaxation standpoint of the smooth muscle cells. So if you take this positive ion like potassium here and we kick it out of the cell, if you take positive ions, kick them out of the cell, what's going to happen to the inside of the cell? It drops, right? The cell membrane potential, or the cell membrane negativity increases. So you have more negativity in the cell, and the difference between the outside of the cell and the inside of the cell is greater. And that is driven by more positivity going outside of the cell and leaving more negativity inside of the cell. So all of this then it means that the smooth muscle cells are going to remain in their relaxed state. And if they are in the relaxed state, then they allow more blood flow because they're not clamping down on the blood vessel to shrink the blood vessel. So the blood vessel is nice and dilated, and you have more blood flow, which can ultimately lead to an erection. Now, the problem here, however, is that if we go back to this cyclic GMP, which just had this effect on PKG, which just had this effect on these 4 different mechanisms, if we look at PKG, and if we look at cyclic GMP, one of the offshoot signaling pathways of cyclic GMP is that it interacts with phosphodiesterases, which are another class of enzymes. Now, these enzymes will convert cyclic GMP to 5' GMP, so to this guanosine monophosphate. And that inactivates, so guanosine monophosphate does not have the same effect that cyclic GMP has on PKG. So if you have high levels of cyclic GMP, you have high activity of PKG. But if you suddenly have this offshoot that starts to degrade cyclic GMP levels drop, and therefore you have less activity of PKG. Hopefully that makes sense. So it stands to reason then what happens, right? Like what could we do in this whole scenario? I mean, there's a number of different things we could do, but like one of the targeting sequences that we can use as scientists is then to find some sort of inhibitor, some sort of molecule that will inhibit the phosphodiesterase, and it's the I is for inhibitor, will inhibit the phosphodiesterase. Now, if you inhibit the phosphodiesterase, you have less of this conversion of cyclic GMP to 5' GMP, and then you have higher levels of this PKG activity, and all these mechanisms can then be forthcoming and work. And therefore, then you have this greater potential for the relaxation of smooth muscle cells and then erections to occur. So there's a particular phosphodiesterase that's specific for this conversion within the smooth muscle cells, which is called phosphodiesterase 5, because there are many different isoforms, different versions of phosphodiesterase. And that's going to be important as I'm going to show you in just a few slides. But for the time being, the way Tadalafil works is that it is a PDE inhibitor, and it inhibits phosphodiesterase and therefore lowers the suctioning of cyclic GMP to 5' GMP, and therefore elevates cyclic GMP, and therefore you have higher activity of PKG. Now, another mechanism that's also used is through the accentuation of testosterone. So just straight up, just adding testosterone, because what does testosterone do? It can also have an effect on our cells to the point where they produce more using nitric oxide synthase, which is the enzyme that allows for the production of nitric oxide, obviously nitric oxide synthase production. It can increase, so on this end, so I mentioned that there are a number of different mechanisms, right? Like we could target any one of these. Some of them have more offshoot problems or off-target effects that could happen, and therefore we don't focus on those because they could have negative effects in other ways. But this is one that would be specific to phosphodiesterase 5, and therefore you're going to have specificity to this particular section of the pathway. Now this one, you're going at the very beginning of this entire pathway, of this entire signaling cascade, and you're increasing nitric oxide production. So testosterone increases nitric oxide production, which then Obviously, if you have more nitric oxide, then you have greater activity of guanylate cyclase, greater conversion of GTP to cyclic GMP. And even though you still have this conversion to 5' GMP because phosphodiesterase is not inhibited in this situation, you can still get some information here, or you can get some benefit, I suppose I should say, because you're hyperactivating guanylate cyclase so that it's constantly producing more cyclic GMP. It may not be quite as efficient as straight up blocking this pathway, but it will still work. You'll still see a disproportional increase in cyclic GMP because phosphodiesterase can't get rid of the cyclic GMP fast enough. So on average, you still see an increase in cyclic GMP. So that's how testosterone would work. Now, that said, there's also this idea that, and why we're investigating this as well in this video, is that Tadalafil can also seem to have an effect, potentially, we'll see what the data shows, on testosterone production. So how does it do that? And this is a proposed mechanism. I think that there's still some evidence that needs to come out for this. I wasn't able to find a whole lot on this, but this is what I've found, according to some of the papers that I read, as well as some offshoot papers that I read. Well, I shouldn't say I read them. It was more like I skimmed over those offshoot papers. Otherwise, I'd be reporting exactly what they say here. Anyway, so typically this is how testosterone I'm truncating this a little bit, but typically this is how testosterone is produced. So now we're in the latex cells. So we're in the cells of the testes. And we've got what's known as a G-coupled protein receptor. So it's a GPCR. I always get those letters mixed up. GPCR. G protein coupled receptor. That's it. Yes. GPCR, which is a type of receptor that essentially is embedded in the cell membrane. And you have luteinizing hormone, which gets produced and then ends up binding to the outer section of this GPCR. Then the GPCR has a conformational change where you have these proteins on the inside of the cell, which get, they change their structure slightly to the point where one of the sections can then interact with this adenylate cyclase. And through the interaction, or the activation, I suppose I should say, of adenylate cyclase will then take ATP, so the adenosine triphosphate that we're very familiar with from mitochondria, because mitochondria are the powerhouses of our cells. They take our nutrition substances, our nutrient substances, and turn them into ATP. So we have high levels of ATP. So adenylate cyclase, once activated, will start taking that ATP and converting it to cyclic AMP, so cyclic adenosine monophosphate. And this cyclic AMP can then interact and activate pKa. So remember, we had a pKg in this situation right here. Go back here. pKa is another one of those types of proteins. So pKa will be activated, which will then activate another a signaling protein, transcription factor known as CREB, which is a really common one. CREB transcription factor, which will go into the nucleus of your cells, will bind to steroid genes. Yes, testosterone is a steroid, so that's why I kind of just universally labeled it steroid gene here. Will bind to the steroid genes and then lead to the eventual production of testosterone. And then testosterone gets kicked out of the cell. Now, I just described this entire flow, but I did not describe this. So another mechanism for cyclic AMP is the clearance of cyclic AMP. Just like what we saw, if you'll allow me to go back here real quick, just like what we saw with this cyclic GMP to 5' GMP, we have cyclic AMP, which gets degraded to 5' AMP. And who does that? What does that? It turns out it's phosphodiesterases yet again, except, and this is why I mentioned that this is important for you to know, that we were talking about phosphodiesterase 5 earlier. Now, this is a different isoform. This is a different version of phosphodiesterase. So I think it's phosphodiesterase like 2 or 3, one of those numbers, somewhere in that line. And the proposed mechanism that tadalafil might have, I just have to be very clear about that because I think that the evidence that I saw it didn't seem that clear, that it may have some off-target effects which may not only affect phosphodiesterase 5, but may also affect these other phosphodiesterases. Not all of them necessarily, but the ones that would convert C-AMP to 5' AMP, which would then mean that if you can inhibit this, then you're going to increase the amount of cyclic AMP, and therefore you're going to have more drive through this pathway right here. So that's the idea of how phosphodiesterase inhibitors, not just tadalafil, but just in general, phosphodiesterase inhibitors will increase the ability for smooth muscle cells to relax and therefore increase blood flow and therefore increase erections. And secondly, may also increase testosterone through this kind of offshoot mechanism as well. Okay, folks, let's go on to testosterone. Let's actually look at the evidence for, does tadalafil actually have an effect on testosterone? And we're going to start with looking at this study. So study 147, there is internal funding, so it's largely public funding. So this is nice to see in terms of conflicts of interest. Me there's some issues here. So if we look at the study design, the way this was done is let me go back, it was 147, so let me open up my notes here real quick. So we have 40 men with metabolic syndrome, so that would be like diabetes, hypertension, obesity, things of that nature, and erectile dysfunction. Obviously, if you're going to find out if tadalafil has an effect on erectile dysfunction, I know we're looking at testosterone, but we're going to return to this for the erectile dysfunction portion. Just for the time being, we're going to look at the testosterone. So, but you do want to know, for once we get to the erectile dysfunction portion, do these people have erectile dysfunction? Because how can you see an improvement in erectile dysfunction if these people don't have erectile dysfunction? Okay, that's it. So it was 40 men with metabolic syndrome and ED. They were 57 years of age. Now, there wasn't that much information on them, to be honest with you. There was no report on their weight or health markers of any other sort, which isn't great. Additionally, this study was not randomized, which means the people were not randomly allocated to one group or another group, obviously because, well, there's one group, so there's no randomization. And the reason why there's no randomization is because there's no placebo group. There's no control group. There's no placebo group, and on top of that, there's no control group. So at the very least, it would have been nice to have a control group. So there's no blinding, obviously. Well, I guess maybe they could have blinded the individuals, but they didn't even do that. So they could have just not told the individuals what they were consuming. So if they were consuming a sugar pill or whatever it might be, they kind of told them that, but they were actually taking tadalafil. Maybe that wasn't. Maybe that's not in the cards with the IRB, so the Internal Review Board. So either way, the point is that the study design is not great here. And this is repeated measures. So they just took measures at baseline, and then they compared it to measures 12 weeks later. So after 12 weeks of taking tadalafil, do you see an increase in testosterone? So we're looking at a few different metrics here. We're looking at, so here we've got our baseline. Here we've got our treatment, so that's tadalafil. Here we've got our total testosterone. Here we've got luteinizing hormone. Here we've got follicle stimulating hormone. All these hormones are intimately intertwined with one another, but we're going to be focused on total testosterone. I'll talk a little bit about luteinizing hormone as well. So, again, the way that this data is displayed is not great. Typically, you want to see actual error bars and standard deviations and things of that nature, which they don't do. That sucks. I'm not happy about it, but what's odd is they actually do end up showing the standard error of the mean, the error bars, when we look at the data again later on. But for some reason, they just didn't add it here. Kind of weird, but whatever. They also don't have an indication of what this axis is, which is another thing that you typically want to do. I realize that it says nanograms per milliliter. These are all different from one another, but there still should be some identification on the left side here. Anyway, I'm nitpicking. So for total testosterone, yes, there is an increase in total testosterone. Clearly, if you look at this bar, the average, versus this bar, the average, then from baseline to treatment, clearly there's a pretty sizable difference in total testosterone from the consumption of Tadalafil. Now, the other thing here, which I found intriguing, is that there was a reduction in luteinizing hormone, which luteinizing hormone is the one that, as I mentioned before, if you'll allow me to go back here real quick, and you know what, I noticed when I was doing this that I didn't actually show you the image because my big face was taking over the screen. That luteinizing hormone is the one that binds, that leads to all these downstream effects that ultimately leads to the increase in testosterone, which is really intriguing because we see a drop in luteinizing hormone. So it's possible, I'm just speculating here, complete speculation, just to be clear, that maybe because of this increase in testosterone, the body starts to produce less luteinizing hormone. You have a lot of feedback mechanisms between these hormones. So if you have, so that you don't, massively overproduce testosterone or massively overproduce luteinizing hormone or any one of these different hormones. And that happens with so many of our hormones. All our hormones are intertwined where they have these feedback mechanisms. So it's possible that you see this increase in total testosterone and then you see a reduction in luteinizing hormone. And because you're affecting it downstream here, let's say you were to inhibit this phosphodiesterase, even with lower luteinizing hormone, you're having such a strong effect on maintaining cyclic AMP levels high that this still drives an increase in testosterone. I'm just guessing. If you have a better theory, a better hypothesis, please comment below. I'd love to hear it. And we'll see if we can come up with some other plausible explanations. So anyway, that's the results. Total testosterone increases, luteinizing hormone decreases a little bit. The next one is to look at study 148. Let me pull up my notes here. Study 148. We have industry ties. So unfortunately, the researchers had ties to industry. I think the funding was from a particular industry. And again, if you want to know more notes on all that stuff, you can check out my notes. So, take it with a grain of salt, potentially. Now, for this one, it was slightly better than the previous study because they did have a group that took Tadalafil and they had a group that was just a control group. So these individuals just didn't consume Tadalafil. Compared against age-matched, non-erectile dysfunction experienced controls, but they didn't take a placebo. So not exactly the best design, but I would argue it is better than the last study. So we've got 20 men with erectile dysfunction. These individuals were mostly normal weight. There were a few people that were slightly overweight. And they consumed Tadalafil, and they had normal testosterone levels. They were 54 years of age, and as I mentioned, normal weight. So the problems here is that it's not randomized, obviously, because these are two completely different groups, right? One group has erectile dysfunction, the other group does not have erectile dysfunction, so you can't mix them. So it's not randomized. So these people also know that they're taking Tadalafil. So that means that whatever effect we see, we can't distinguish between a real effect and a placebo effect. And sometimes I get comments from people saying like the placebo effect is not real. That is complete nonsense. I've covered many studies on this channel, on this brand, that have shown a clear, strong placebo effect, which have sometimes nullified the entire effect of the treatment. So I would strongly disagree. So no blinding, but this was what was really positive was it was 12 months long. So that's really interesting. And ultimately, if there is a placebo effect, but you see an improvement, do you care? You should think about that because in this scenario, maybe you don't. Okay, so here we've got a number of different hormones. Again, we've got sex hormone binding globulin. which binds our different hormones like testosterone. So it'll bind to testosterone and essentially take it out of circulation. Technically, it's still in your bloodstream, but it's inert. It can't be unattached and then go into your cells. The only one that we're most interested in is free testosterone, and total testosterone will tell you some information as well. So with sex hormone binding globulin, we've got our controls, which are the people without erectile dysfunction. They're healthy. They're not taking Tadalafil. They're just being compared against. They're just taking values and then comparing against those values. We've got our Tadalafil group at baseline. So this is before they're taking Tadalafil. Then the Tadalafil at 3 months, so after taking Tadalafil for 3 months, and then at the final time point of 12 months. So that's kind of nice, honestly. I like the fact that they did it this way. This part is nice. So for sex hormone binding globulin, there's no effect, no difference across the board, and no effect of Tadalafil. For total testosterone, there is no effect, interestingly enough. Now, you could argue that maybe, allow me to go back here real quick, and I'm going to get into a little bit of statistics here. You could argue that a N, or a sample size of 20 individuals, may not have been strong enough to actually detect an effect between, let's say, the control or the Tadalafil at 3 months, because you can see both bars are pretty far away from one another, and the standard error isn't that huge. So it's possible that these are approaching statistical significance, and I would bet maybe that if they had done a different statistical test known as a t-test. Now, before everybody with statistics knowledge yells at me that these are multiple comparisons, so you can't do a t-test. If they had done specifically a comparison of just 2 of the conditions, so let's say the controls or actually probably would have been more, which would have been more appropriate as Tadalafil baseline versus 3 months or versus 12 months. So 2 comparisons. If they had done a t-test, they might have seen a difference actually between this black bar and this dark gray bar. But as it stands, they did ANOVA, which is the correct statistical test if you're going to do multiple analyses, and they found no difference. But I would actually really like to see the p-value on this one, because maybe it's like p-value of 0.1 or something like that, which would be pretty darn close. Okay, so estradiol. So looking at estrogen levels, we do see an effect of Tadalafil on estrogen levels, reducing estrogen levels and increasing the ratio of testosterone to estrogen. So while testosterone did not statistically significantly increase, estrogen did drop, and therefore we see an increase in the testosterone to estrogen level. That's driven by the drop in estrogen. Now, in terms of free testosterone, again, we don't see an effect, but we see the same trend. Kind of looks very similar to the total testosterone levels. And here, with luteinizing hormone, we see no effect. So there could be some differences between the individuals from study 147. It was 147. Yeah, 147 here, and the individuals from 148. So again, these were normal weight. We don't have that much information on the other ones, except that these individuals had metabolic syndrome. So it's possible that that is the distinction. So most likely, I would guess that these people are overweight, but I don't know that for a fact. So there are some distinguishing features of why this group may have seen an effect on total testosterone as well as luteinizing hormone that may be driven by the fact that they have metabolic syndrome. And these people were normal weight, generally healthy except for having erectile dysfunction and seeing no effect on testosterone. So that, just keep that in mind. The next study is to look at study 151. So study 151 is public funding, which is great to see. So probably no conflicts of interest other than potential personal bias. And this is, again, slightly better than the previous study even. So the previous study had a control group. It did not have a placebo. And this one also does not have a placebo, but they do have a comparison group. So 40 So for this one, they had 43 men with erectile dysfunction. Again, they're roughly 48 to 49 years of age. They were overweight. They were randomized, so randomly allocated to either the Tadalafil condition or the Tadalafil on demand. Now, allow me to explain that. So for one condition, Tadalafil, they took Tadalafil every single day. The other condition, they took Tadalafil on an as-needed basis, so as wanted. So if they could go maybe 3 days without taking it and then take some. And then maybe 2 days later, they'll take some more. It's however they felt they needed to take Tadalafil. We will not be focusing on this as much because there are way too many variables in this condition that could ultimately lead to improper conclusions. This one, they were instructed, take it every single day. This is the more telling condition. Now, that said, there's still no placebo condition, unfortunately, and there's no blinding in this situation because this was open label. So they definitely knew they were taking Tadalafil, and they were taking it as needed in this condition. It was 8 weeks long, and it was parallel design, so we're comparing this condition versus this condition. However, they do also do a comparison of baseline versus post, so looking at the pre versus post conditions. Okay, so we've got a lot of information here. We're going to be going over more than just testosterone levels for this condition. We've got our once-a-day Tadalafil. This is OAD, once a day. Tadalafil, we've got our mean age of 48 years old, 49 years old, so no major differences. And then we've got our on-demand or as-needed condition. So I'm going to be focused on this side, but if you're interested, you can also look at this side for yourself. But I'm going to be focused just on this left side. So we've got our baseline values right here. So this is before they were on Tadalafil. And here we've got, I suppose I should remove myself for a second so you can see this. This is OAD-TAD, just for reference. So yeah, we've got our baseline here before taking Tadalafil. Then 2 months, remember it's 8 weeks long, the entire study. So 8 weeks on Tadalafil, what's the measures afterwards? And then 2 months after taking Tadalafil, they stop taking Tadalafil. Are there remaining effects after the fact? And then we've got our p-value. Now, to evaluate a p-value, typically the statistics for most studies indicate that there's a statistically significant difference. Just a difference, doesn't tell you more or less, just a difference. If the value, the p-value is below 0.05. I know that if you've been following Physionic for a while, I repeat that a lot, but it's important because some people might be watching this for the very first time, and just to orient you. So we're looking at the values on the left side here so left side under baseline. These are the average values, and then over here we've got our, I believe these are standard error of the mean. I'm not entirely certain, though. I should probably check that real quick. Let's see here. Unfortunately, they don't say. Yeah, I don't see it, unfortunately. So I think it's standard error of the mean. But I will add a amendment if that turns out not to be the case. So, and that's for the people that actually know what standard error of the mean is. The most important, though, is to compare the average. And then for those of you that have a little bit more statistics knowledge, you can look at the standard error of the mean. So we're looking at weight, BMI, waist circumference, lean mass, so that's bone mass, muscle mass, etc., fat mass, total testosterone, estrogen, total testosterone to estrogen ratio, SHBG, as we looked at it earlier, which binds to testosterone and essentially removes it from being able to be used, and insulin levels. So I thought I'd throw that in there as well. So what do we find? Well, we find that for weight, there are no differences. So we don't see any effect of Tadalafil on weight. Obviously, nothing on BMI. Waist circumference, no differences. Lean mass, no differences. Lean mass, I will be returning to because it goes from 76.2 to 76.5. And that seems like nothing, and it is statistically non-significant, but we're going to return to this because they end up looking at this a little bit deeper. Fat mass, no differences. Again, 21.6 to 21.1. I just want you to pay attention to that because the next piece of data that I'm going to show you is going to show you something really intriguing. Total testosterone, no effect. So no effect for these individuals. We'll return to that in just a second. Estrogen levels, however, did drop, consistent with what we saw in the previous study. So yeah, I'll return to this in just a second. So there is a statistical significant difference, and after 2 months withdrawal, it returns back to where it was. So if you stop taking Tadalafil, then you do see a reversal of the estrogen effect. And then again, as expected, even though total testosterone didn't change, estrogen did drop, and therefore the testosterone to estrogen ratio does increase, consistent with the other study. And again, that reverses once you stop. SHBG, again, no effect, consistent with the other study. And insulin levels, which was really intriguing. This is really, really interesting to me. And I don't exactly know why. I can't think of the mechanism off the top of my head. If you can think of it, please post below. I would really be interested to hear your thoughts on why we see a substantial increase in insulin levels with the addition of Tadalafil. And would you consider that worrisome or a positive? Because this actually technically doesn't speak to the insulin sensitivity effect. It just speaks to an increase in insulin levels. So we see that insulin levels increase rather robustly, and then they return back to normal or back down to baseline values after stopping Tadalafil. And again, I'm not going to cover everything on this side, but I just wanted to show you regardless. So let me discuss this total testosterone estrogen bit a little bit. Again, we have to look at these areas over here. So for the overweight individuals, which is most likely what I don't think that these individuals had insulin resistance. They didn't have diabetes or anything like that. We see that it's more consistent with this study over here, which was study 148. With study 148, we see a drop in estrogen. We see an increase in the testosterone estrogen ratio, but we don't see an effect on total testosterone, which is exactly what we find here for study 151. So we're starting to get, like, some people may experience one effect where you do see an increase in testosterone, and some people may not experience an effect on testosterone, but do seem to experience an effect on estrogen levels. And it's possible, if you allow me to go back here real quick, that for study 147, that they didn't measure estrogen. So it's possible that there's also an effect for these individuals, but they also see an increase in total testosterone. Okay, so I mentioned that there's going to be some more data, and that we should focus on lean total and fat total percentage. The reason why I mentioned that is because they also wanted to look at specific sections. So here they're looking at trunk and android. So android is further down on the body. Lean mass in the trunk, obviously throughout the middle section of your body. And then fat android. So again, lower part of the body, but fat mass specifically. And what they find is that although, and this is far more sensitive, excuse me for going back here real quick, we're looking at percentages here. And they're looking at, okay, it's not 21%, it's 21.6%, which is nice, but the sensitivity of a percentage basis here is not nearly as sensitive because you get 3 significant digits. You have 21 to 1.6. Look at this. We're looking at grams. And we're looking at 35,000. We're looking at 5 different digits to try to tease out differences. So this is a prime example of what I'm talking about when I rail about looking at effect sizes. So how much of an effect is there really? So yes, there's a statistically significant increase in lean trunk mass and lean android mass, which would be considered, you would need to really break this up into like organ tissues and be able to determine, like, is that from muscle mass and things of that nature. But as it stands, let's just assume for a second that this is a positive. Let's just take that, but I'm not arguing that it necessarily is. Let's just say that it's a positive. You see that there's an increase from the baseline to 2 months, and then it reverts back after 2 months of withdrawal. And it's the same thing here. And we do see a reduction in fat mass here, which obviously would go in the opposite direction. So this would be considered probably a good thing. And then it reverts back once you stop Tadalafil. So let's assume that this is from let's say muscle mass or something along those lines. So which we would need actual tests to be sure of that. The actual effect of going from this to this, the effect size, we're talking about, let's say 33,000 grams is at baseline, and at the 2 month mark we're at 34,000. Let's just say you might disagree by 500 or something. That's fine. 34,000. So that's 1,000 grams. That's not nothing, but it's also not a huge amount. I mean, we're talking about a pound. We're talking about literally a kilogram. So I guess 2 pounds, something along those lines. That's not nothing, but I doubt all of that is muscle mass, for example. Now, in this situation, you're seeing a little bit more of an effect. So you're seeing from let's say 3,800. So obviously there's a lot less fat mass than this is 5 digits, this is 4 digits. So 3,800 to 3,200, something like that. So 600 gram difference. Yeah, I mean, it makes a difference, but it's not breathtaking results or anything like that. And that's probably why we're not seeing huge differences when we're actually looking at the percentage. Because keep in mind, this is also a 2 kilogram difference in a particular region of the body. And this is looking at the overall effect. So this is something, but it's not as huge as I think a lot of people might think that it is. So overall, I'm not blown away by these results, but it does seem that Tadalafil, even though it doesn't have, in these individuals, have an effect on total testosterone, that, you know what, now that I think about it, it could have an effect on free testosterone. They just didn't measure it, which is certainly a possibility. So that may be why we see this increase in lean trunk and then this reduction in fat mass as well. Okay, moving on to erectile dysfunction. I'll go into the actual conclusions on testosterone a little bit later on because there's a little bit more information that I need to give you on the first study that we went over. But it seems like Tadalafil only has an effect on testosterone in particular individuals. I'll give you a hint in that regard. And let's go ahead and return to that first study again. So this is study 147, so the same study that we looked over again. This is the one without the blinding, without the placebo group, even though it was internally funded and public funding, and repeated measures, so we don't have a comparison group. Now here we're looking at the same data. Remember, we had these markers right here. So this graph that I mentioned didn't have the standard error of the mean, and then for some reason they ended up adding it here. So we've got total testosterone, LH, luteinizing hormone, and follicle stimulating hormone. We can actually see the comparisons, which I wish, again, that they'd just done that before. And what I'll note here is the reason why I wanted to add this is because if you actually look at the numbers themselves, 3.6 nanograms per milliliter, we're talking about probably hypogonadal men here. And we see that there's a pretty substantial boost in testosterone with Tadalafil treatment, up to 5.2 nanograms per milliliter. So the other two studies on testosterone indicated that those individuals had normal testosterone. So it's possible, even though this is the only study, I have one other study that I cover later on, but this is the only study that actually indicates that if you have very low testosterone, that then you see a boost in testosterone from Tadalafil. So it may be specific to the fact that your starting point in testosterone has an effect on if Tadalafil has an effect on testosterone. Normal testosterone, you may be fine. There may be no effect. And if you have low testosterone, there may be an effect. So I'll cover that again once we get to the conclusions for those of you that end up skipping. So the other factor, however, is to look at IIEF. So IIEF is something we're going to see multiple times throughout this, and it is the indication of erectile dysfunction. So if you have a higher number, the better. That means you have lower erectile dysfunction or greater erectile function. I guess we'll put it that way. So IIEF, the greater the number, the better the erectile function. And what we see is that, and this is survey based, so it's not like a perfect metric. And this is exactly why a placebo group would have been excellent for this, because you might still see an improvement in people that, oh, I'm taking something, so I think something is happening, and therefore then I'm going to write down in my survey, yeah, I feel like things have improved. But these are questions like, are you able to get an erection before sex? Is sex pleasurable? Like things like that. And typically people aren't going to be too bombastic about that stuff. Like if they see no improvement, I think they can tell if there's no improvement. But still, this is the kind of stuff that you absolutely need a placebo to be really certain of the effects. So take this with multiple grains of salt. But we see a huge increase in erectile function from baseline versus treatment. So going from 11.3 on that survey, that chart, versus 19. So a huge increase. Hey, did you know that 30% of men actually still experience erectile dysfunction even when they use Tadalafil, or really any phosphodiesterase inhibitor? Well, in my insider's version of this video, I actually go into the reasons why and potential solutions for that to increase sensitivity to Tadalafil. So if you're interested in accessing that, plus a whole host of other content that's exclusive to the insiders, including live sessions with me, seminars, research reviews, and all kinds of other things, then consider joining the Physionic Insiders. It's a great program, or at least I think so, since I've put a ton of work into it. It's a smaller community. You get a lot more focus on your questions, and you'll get greater access to be able to ask me questions and things of that nature. So if you're interested, then hop on over there. And without further ado, let's get back to the video. Now, this one is study 150. There are conflicts of interest. Let me describe to you what those are. I think, one, it was industry ties. So this was, I don't want to speak out of turn. I'll add that to the notes that I have. But for sure, it has industry ties, meaning that it's funded, at least funded by industry. And for this one, it's a slightly different system because it's intriguing. They end up applying testosterone plus Tadalafil to see if there's an effect. And this is a crossover design study. So we've got 29 men with erectile dysfunction, obviously, 57 to 60 years old, normal weight with low testosterone. These individuals were not randomized, obviously. There's no blinding, obviously. There's no condition here. The study lasted for 24 weeks with 12 weeks in each condition. So what do I mean by each condition? Okay, so for one group, they took TRT, testosterone replacement therapy, alone for 12 weeks. Then they took TRT plus Tadalafil. That's group 1. Group 2 took Tadalafil plus TRT in the first 12 weeks, and then they took just TRT in the final 12 weeks. So this crossover design, so group 1 would be TRT, TRT alone here, then they cross over, and then they do TRT plus Tadalafil. The other group takes Tadalafil plus TRT, then they cross over, and then they take just TRT alone in phase 2. So let's look at the baseline values, because this study actually reported on the baseline values. And it's important here that I mention this because there are some differences between the two groups before they even start the study. So this is as they're recruited. And this is where randomization can kind of help, because it can make sure that there isn't too many people with a slight difference that is significant from the other group at the beginning of the study, which, if you've heard me speak on this before, you know that differences at the beginning of the study can unfortunately confound the results that we get at the end of the study. And we can control for that in certain statistical means, but I'll get to that once we actually get to the data. Okay, so what are some of the differences? Some of the differences are, if you see a star, again, the p-value is under 0.05. That's statistically significant. If you see something that's somewhat close, you could make an argument that that may be statistically significant, especially when you have only 14 people in group 1 and 12 people in group 2. Now, I said that there are 29 people in total. That's because you have a few people that end up dropping out. So the actual, what the statistics are run on, is just the 14 people in group 1 and 12 people in group 2. And I'll remind you what those groups are in just a little bit again, because it's a little much to get exposed to once. So for group 2, these people are slightly overweight, 25.4. I mean, they're right on the border of normal weight and overweight. And yes, BMI, I get it. There are problems with it. But overall, for the general population, it's a relatively okay marker of being overweight or normal weight. For group 1, they're normal weight. Now, if we go down here, we also see that total bilirubin is different. Now, how that might affect things, we don't know. You'd have to think about like some physiological mechanism that could somehow impact the results. But what does get affected is this free testosterone difference. We see a pretty substantial difference between group 1 and group 2 in free testosterone. I think that's kind of a big deal, and can really be a confounder for future results. So just keep that in the back of your mind. All right, so now to look at the results. Remember, group 1 took TRT. So let me break this down. We've got group 1. They're taking TRT alone for 12 weeks. Phase 1 is TRT alone. Phase 2, once they cross over, is TRT plus Tadalafil. Group 2 is the group that was overweight with slightly higher free testosterone. Remember that. Phase 1, they were Tadalafil plus TRT. And then phase 2, they were TRT alone. Okay, so just to orient you. I'm not going to go through every single one of these, but let me go through some of these because I had to look them up as well. It's not like I'm an expert on all these different like AMS score. Like I don't know about erectile dysfunction scores and all that stuff, but obviously I know a good amount about testosterone, PSA, and all that good stuff. So for AMS, a higher score is worse. Erectile dysfunction score, so IIEF, a higher score is better. IPSS, which is a prostate questionnaire on ability to pee. So can you pee? The higher the value, the worse. AMS worse, higher. IPSS worse with higher. And OABSS, so overactive bladder score, higher is worse. So the only one that's better is if you get a IIEF score that's higher, that is better. All the other ones are worse for your health, if you want to label it that way, with that metric. So AMS, IPSS, OABSS. Okay, so that said, what do we see for phase 1 versus phase 2? So this is a comparison between phase 1 versus phase 2. We see that there are no statistically significant effects, except for maybe you could argue for hemoglobin here. But the effect size is pretty small and probably doesn't make any difference whatsoever. So we see that moving from, I always have to remind myself, TRT alone for 12 weeks to TRT plus Tadalafil, there seems to be no effect across the board. So no change in the AMS score, no change in the IIEF-5 score, even though if you look at this, like just look at the plain values, it's pretty interesting that the statistical significance is so far away at 0.22 when the value goes from 6.5 to 11. When you look at the previous study that we looked at, let me go back here real quick to show you, from 11.3 to 19. and there was a strong statistical significance. See, that really indicates the number of individuals that you have in the study really makes a big difference in terms of if you have enough what's called statistical power to detect a difference. So I could make an argument that there actually is an effect in the IIEF-5 score here, but as it stands, technically there isn't. So no differences across the board here. Now, when we look at the actual phase 1 versus phase 2 of group 2, we see that, so phase 1, again, just as a reminder, I know I keep reminding you, but I'm also reminding myself. Phase 1 is to go for Tadalafil plus TRT to then just TRT. And what we find is that there's a worsening of the AMS score. There's a worsening of this somatic domain AMS subscore. So this is, I guess, subfractions of the same exam, not things that I'm that familiar with. I'm just trusting the researchers to know what these tests are. I look them up peripherally, so I know that if it's higher or lower, it's better or worse and whatnot. A sexual domain score slightly worsened as well. And then if we look at the IIEF score, we see that there is a drop. So, and it is statistically significant. Whoops. Excuse me. Now, if we look back here, again, this is the one that had higher free testosterone. So could this be, again, another situation where you have a testosterone effect, even with the addition of TRT, that you see an improvement when you're taking Tadalafil specifically? I don't know. I'm just speculating. And then the OABSS score also did not improve. So it got worse, I should say. Although the IPSS seems to be approaching statistical significance, but it's still statistically not significant. And it seems like it's actually improving, but as it stands, it's not statistically significant. So across multiple metrics, the removal of Tadalafil, how to translate this, is the removal of Tadalafil and only looking at testosterone, you see a negative effect, so that you see a reduction in the betterment of these different symptom scores. And finally, I wanted to incorporate this as well. I think they had one other piece of data or two other pieces of data which actually show the same thing, just in graph form. I wanted to point out the preference that these individuals had. Now, there's a problem here in that, if you allow me to go back here real quick, this is not blinded. So they know they're taking Tadalafil and they know they're taking TRT. So that's a pretty big glaring issue with this study design. But would people prefer to take TRT only, or would they prefer to take TRT plus Tadalafil going forward in their life? And the vast majority said they would rather take both of them at the same time. Now, is this a placebo effect? Do they think that they're just going to do better if they're just taking more things? You know how people get really obsessed with supplements? They take like 50 different supplements because they think each one of these is going to give them everlasting life and things of that nature. Not that I have a problem with supplements or anything like that, but there's people that take everything under the sun in hopes of just with a shotgun method, this is going to better their performance, their health, their longevity, all that stuff. It's possible that's exactly what's happening here as well, that people are like, well, more treatments are going to be better than no treatments, so therefore I'm going to go for more treatments. That's a possibility. But I still wanted to report this because I thought it was interesting that the vast majority still chose to take Tadalafil except for these three individuals. All right, study 151 is the one that I actually went over before. This is public funding, and this is the one where people were taking Tadalafil once a day, or they were taking it as needed. And for this one, we've already gone over all of this data up to the insulin. We already discussed the drop in estrogen, the change in total to estrogen ratio. I said I wasn't as interested in looking at the as needed. This is the once a day. This is the as needed condition. And if you want more specifics and you skip to this section, please go back to this study analysis during the testosterone section, because I go into more detail on how to read this. Again, the p-value is under 0.05 is considered statistically significant. And now we've added the IPSS. Remember, that's the one that if it increases, that's worse. And IIEF, which if it increases, it's better. Okay? All right, so what do we see here? Well, we see if people take it consistently that there is an improvement in their erectile dysfunction, that they see an improvement in their erection capacity and their sexual satisfaction and things of that nature. Now, what's interesting is the taken as needed also sees an improvement. I did want to point that out, that there is an improvement. But then once you stop taking it, there's then a regression back to the baseline values, or at least it's not statistically significant. Now, the IPSS, which is the marker of prostate questionnaire on ability to pee, that one improved. Remember, it goes down. So 7.5 to 3.1, it seems to improve with Tadalafil. We do not see that effect, however, when taken as needed. So it seems like if you were to take it as needed versus if you were to take it consistently, you would see better results if you were to take it consistently. And I can also tell you that these individuals take less than these individuals. So taking it consistently, it's probably because Tadalafil has a relatively long half-life. If I remember correctly, that half-life was like 36 hours or something like that. Or I guess I should say relatively short, but maybe by comparison to other phosphodiesterase inhibitors, it may be a little bit longer. I think I read that in one of the reviews. But ultimately, taking it once a day was superior to taking more of it on a less frequent basis and a less regular basis. That's one of the problems with this, because you don't really have an indication of like, oh, when did you take it once every 2 days? Did you take it once a week? Did you take it once a month? Like, that kind of information is on a as needed basis is kind of sucks. All right, so we're going to go into the effects that it has. So for 30% of the population, 30% of the population are non-responders. So we're going to find out why they may be non-responders. There's a number of different factors, how to potentially improve the effectiveness, as well as going over optimal dosing across multiple studies. So I aggregate all the information from the studies, put them all together, and figure out what the optimal dosing is. And then for the conclusion of the midpoint, so at this point, before we go into these topics, which are specific for the insiders, Tadalafil may raise testosterone in hypogonadal men. Remember, we only had one study on this, though. So it's like, I'm not entirely convinced on this, because the study was shoddy quality. There was no placebo, no control group, no randomization. I think I would want to see much better quality studies to actually really be able to determine if there really is an effect in hypogonadal men that does not affect normal testosterone men. Now, there is one more study I'll be going over for the insiders, but for the most part, I still think regardless we need more studies. But as it stands, hypogonadal men see an effect of Tadalafil on their testosterone, and people with normal testosterone do not see an increase in their testosterone from Tadalafil. However, Tadalafil does seem to improve erectile dysfunction, except for that 30% of non-responders. And with that, if you're interested, certainly, you're welcome to join over on the Insiders program, and we'll get to more of this. You'll get access to a ton more information as well related to all kinds of different other topics, as well as access to me in group live sessions and seminars and research reviews and all this good stuff. There's a lot there. But with that said, if you just want to end it here, then I hope that this was informative. I truly hope that it was, and I'll hope to speak with you in the near future. Have a good one. Bye.